So let's talk about what to do with the factors. So when we're graphing, if I have a factor that looks like x minus 5, well, the zero of that, the zero of x minus 5 is just plain 5. So the zero of x minus 5 is 5. So it's got a nice understood power of 1 right there. If it's got an understood power of 1, that means the curve is going to go through that 0. So if I said I've got x minus 5 to the understood 1 power, that means the curve is just going to go through it like that. It's just going to curve through it. And then it may, it may go on forever. It may turn back around. We're going to have all sorts of issues with that, turning back around. But when I'm just doing this part, so it could be curving that way, or for all we know, could look like this, could be curving down like this. The point is, it just curves through it. It does not change concavity. It does not change concavity. We're going to talk about that in just a second. We're going to talk about concavity in just a second. So when you have a first power, it goes through the curve, does not change concavity. If you have an odd power greater than 1, like x to the third power, this is what we call a point of inflection. That's when it kind of squiggles through the x-intercept. These are the ones where it kind of squiggles through the x-intercept. So the way these would work is like, I've got a 5 right here, and you're going to squiggle, which means it kind of squiggles like this. Or it could be going the opposite direction. Could be going the opposite direction like this. But see, it squiggles through the x-intercept. And this is where we use the word concavity, because if you think about concave, and I'm sure you've heard that before. See this piece right here? See, that would be considered concave down. And then this piece right here would be concave up. So see, it changed concavity at that 0 right there. And that's what's known as the point of inflection. It changed concavity. So concave up, concave down. Anyway, so any odd power, if the factor has an odd power greater than 1, that's roughly approximately the shape of the graph. Our graphs are not going to have to be perfect, eventually, especially when you get to calculus, because like I said, this is going to be a big deal when you get to calculus. The whole concept of the concavity and finding when something's concave up or down makes a huge difference. But odd power greater than 1 creates the point of inflection where you swiggle through the graph. Odd power equal to 1, you just curve through the graph. Then you've got the whole point of tangency. You've got an even power, any even power. This works for any even power. This is what's known as a point of a tangency. And if you remember the word tangent, you're touching something one time. Tangent is when you're touching something one time. So point of tangency, and these are the ones, if you remember, where you bounce off the intercept. So once again, our intercept is still 5. 5 makes this thing go to 0. 5 makes this thing go to 0. This is true for any even power. So 2, 4, 6, 8 for infinity, any even power. So the curve would be coming down like this. It would hit the 5 and then bounce off. Or it could be upside down. It could be like this. It could hit the 5 and bounce off. It might be upside down like that. And we don't know what else is happening. It may curve around like this, may turn around, may go on up forever, but we don't know what else is happening. And everybody says, well, this is weird. No, it's really not weird. You've been doing this forever because you've been saying, oh, look, x squared looks like this. X squared makes that nice curve. It hits a point, turns around and bounces. So it's the same concept. But this is what's known as the point of tangency, when you have the even power and it bounces off the graph. Point of inflection is when you have the odd power greater than 1, where you squiggle through. First power doesn't get a fancy name. It just goes through. So point of inflection, point of tangency. So these are going to be a big deal as we go through this stuff. And we're going to do some examples in a minute. And obviously, I should never say obvious. See, we're already dealing with the factors here. we're going to end up having to factor these problems in order to graph them. That's one reason why we did that first unit.